Hi guys, welcome back to Calculus. Today we are looking at indeterminate forms and we're going to introduce something called L'Hopital's rule, a shortcut for taking limits that are indeterminate. All right, so first thing we got to know is, well, what's an indeterminate limit? So there's lots of different forms that are indeterminate. Indeterminate basically means that one part of the expression tells you to go to one answer and the other part of the expression tells you to go to the other answer. For instance, if we have 0 on top of a fraction, that usually tells us the answer is going to be 0. But if we have 0 on the bottom of a fraction, that usually tells us the answer is either going to be undefined or plus or minus infinity. So these two guys are fighting over which way it should go. Should it go to 0 or should it go to infinity or should it just be undefined? And this is why it's not determined, it's indeterminate what it's going to. All right, for instance, infinity over infinity. Infinity on the top tells us our answer should probably go to infinity. Infinity on the bottom tells us, well, the bottom's really big. That means our answer should probably go to 0. It's indeterminate which one it's going to. All right, so that same thing happens if we have 1 raised to the infinity. We should have 1 times itself and an infinite number of times. It should stay 1, but usually when we're taking limits, it's not going to be exactly 1. It could be a little less than 1, in which case it'll go to 0. It could be a little bit bigger than 1, in which case it might go to infinity. Who knows? Same with infinity to the 0, 0 times infinity, infinity minus infinity, or 0 to the 0. Is it 0 or is it 1? Now keep in mind, when we're talking about all these fractions or all these expressions, they're not always exactly 0 and not always exactly 1. Those limits are just going towards those values. All right, so that means it's not exactly 0, but it's going to 0. And this one's going towards something really, really big. And if we take the limit together, we're not sure what's going to happen. All right, these first two forms, 0 over 0 and infinity over infinity, are really the ones that we're looking at on the AP exam. Like if we get one like this one too, right here, we can always move the 0 to the bottom, and then it's infinity over infinity. So we can kind of do that too. Or we can move the infinity to the bottom, and it'd be 0 over, like 1 over infinity, which is 0 over 0. That still works as an indeterminate form. So something like this is, I guess, sort of fair game. But really, these are the two that we want. 0 over 0, infinity over infinity. And then we're going to use something called L'Hopital's rule, which I'll show you on the next slide. But first up, are these guys indeterminate or not? Well, what happens if we plug in -1 here? Well, the bottom is going to 0. The top, -1 squared is 1. 2 minus 2 is 0. So that's going to 0. So we've got 0 on top, 0 on bottom. So this is going to be indeterminate. Right here, we're going to infinity. We've got 3 times infinity squared minus 1. That looks like it's going to infinity. 2 times infinity squared plus 1, also going to infinity. We've got the infinity over infinity form. It is indeterminate. All right, down here, going to 0. 0 squared is just going to be 0. E to the 0. Well, e to the 0, anything to the 0 power, any number to the 0 power is just 1. 1 over 0. Is that one of these indeterminate forms? No. All right, this is not indeterminate. It's just undefined. All right, in other words, this limit would be does not exist. Or if you wanted to, you could check both sides, and I believe it is going to go to positive infinity. But either way, it does not exist or positive infinity would both be okay answers on the AP exam. How about this guy? Tangent of 0 is 0, or it goes to 0. And then we'd have 0 for the exponent up here. So it would be 0 raised to the 0. Oh, that's one of them right there. So that would also be indeterminate. All right, I'm not saying what the answers are for these right now. I'm just saying that these would be indeterminate forms. So now how do we get the answers? Well, we're really just going to look at the 0 over 0 form or the infinity over the infinity form. So what happens is we have to have it as a fraction. Then what we can do is we take this top function, take its derivative, take the bottom function, take its derivative, and then we try that limit. So the limit goes to the same value with the derivative of the top over the derivative of the bottom. All right, what we're essentially doing is we're saying how fast do these functions go towards infinity? If one of them goes to infinity faster or one of them goes to 0 faster, that'll give us a limit. All right, so that'll get us to our answer. So the rate that we're increasing or the rate that we're going towards those values helps us get those same answers or that limit answer. All right, this also works for one-sided limit. So if we're going to the c to the right or c to the left, this would still work. And remember, this is not the quotient rule. It's not bottom times root of the top times minus top times root of the bottom over the bottom squared. It's just the derivative of the top function, derivative of the bottom function. We're not doing any sort of quotient rule. All right, so now the tricky part. In the last 2 years, they've changed what you can say on the AP exam. So we do not want to ever write 0 over 0 or infinity over infinity on the free response. If you write that, they take off points. Don't do it, all right? Because that's technically bad notation. All right, 0 over 0 is meaningless. Infinity over infinity is meaningless. What you actually want to say, so you can do this in your head and see, is it going to these values? And then you want to write out that the limit of the top, whatever the top function is, either goes to 0 or infinity. And then the limit of the bottom function, whatever that is, goes to 0 over infinity in two separate statements. Then say, because of whatever you're getting, it's indeterminate. State you're using L'Hopital's rule. You can just say LHR if you want. If you spell it wrong, they don't take off points, guys. Don't worry. It's French. It's a guy's name. And then use the rule to find the limit. So then we can do L'Hopital's rule, take the derivative. We can do it as many times as we want. And let's take a look here. So first of all, is this indeterminate? So if we plug in 0 on the top, and I'm just going to do this in my head. So we get e to the 0 minus 1. 1 minus 1 is 0. The bottom, we're clearly going to 0. So the top 0, the bottom 0. So what we want to write is the limit as x goes to 0 of e to the 2x minus 1 equals 0. And the limit as x goes to 0 of just x, the bottom, also equals 0. This is kind of a cheeky way to do it. We just write each one equals to 0. Then we can say it's indeterminate. And we're going to use L'Hopital's rule. And then what we do is we say that this equals the limit as x goes to 0 still. We take the derivative of the top. Derivative of e to the 2x is 2e to the 2x. Derivative of that minus 1 is 0. Derivative of the bottom is 1. And now we plug in again. So on top, we're going to get 2 times e to the 0. On the bottom, we still got 1. E to the 0 is 1. 2 times 1 is 2. So our limit here, this guy, is actually 2. Easy peasy. All right, L'Hopital's rule is generally not difficult, guys. So it's not trying to be difficult. All right, so this guy, if we plug in infinity, natural log of infinity, it's going to infinity. 3 times infinity, also going to infinity. But we can't just say indeterminate and move on. We got to write out that the limit as x goes to infinity of the natural log of x equals infinity, or goes to infinity. We can put the arrow if we want here too, is probably more correct. And the limit as x goes to infinity of 3x also goes to infinity. So now we can say it's indeterminate. We're going to use L'Hopital's rule. So now this limit is equal to, so it's the same limit value that we're going to. And now we take the derivative of the top. Derivative of ln of x is 1 over x. Derivative of 3x is 3. So now I can take this limit. 1 over infinity is 0. 3 is just 3. 0 over 3 is 0. What happens here is that 3 to the x is going to infinity a lot faster than ln of x. ln of x is one of the slowest things that goes to infinity. You can think about the graphs if you want. ln of x looks like that. 3x is a line with slope of 3. It's going to infinity a lot faster. So, and this guy's the one on bottom, right? So it's the bottom guy here. So it ends up giving us 0 because the 3x is going to infinity so much faster than the ln of x is, that the bottom thing is so much bigger than the top, it's going to 0. All right, let's take a look at this guy. So we've got the limit as x goes to 0 of sine of 2x over x squared. All right, so we can kind of do this in our head. Sine of 0 is going to 0. X squared, when we're plugging 0, is also going to 0. Okay, so now we need to write it out. The limit as x goes to 0 of sine of 2x equals 0. And the limit as x goes to 0 of x squared also equals 0. So now we want to state that it is indeterminate. We want to state that we're using L'Hopital's rule. And then we want to state that this equals the limit as x goes to 0. We want the derivative of the top. Derivative of sine is cosine of 2x times 2 over the derivative of the bottom, which is 2x. Now, as we go to 0, at the top, cosine of 0 is 1. 1 times 2 is 2. Bottom, as we go to 0, is 0. 2 over 0 is undefined, so this limit does not exist. So we can still get does not exist as an answer. All right, 0 on the bottom still gives us a problem if there's a number on the top. All right. More examples. All right, so now we want to see, does this guy go to, what does it go to? So we have negative infinity squared, still going to infinity. And by the way, if it went to negative infinity, that would count too as going to infinity. E to the negative infinity. All right, well, that's going to, those negative signs are going to cancel out. E to the infinity is going to infinity. All right, so it's going to be indeterminate, but we got to actually write it out if this is the free response. It's the multiple choice. You can write whatever you want. All right, so we've got x squared goes to positive infinity. The limit as x goes to negative infinity of e to the negative x also goes to positive infinity. So we are indeterminate. We're going to use L'Hopital's rule. So we get that this guy is the limit as x goes to negative infinity of 2x over negative e to the negative x. Now, if we take this limit again, it's still going to be undefined, or still going to be indeterminate. All right, we still have infinities on the, now it's negative infinity on top, negative infinity on the bottom. We're going to keep using L'Hopital's rule. We're just going to keep doing it again. You can do this as many times as we need to. We get 2 on top. We get another negative, so we're going to get e to the negative x. So now we've got 2 on top. The bottom's going to infinity, so this is going to 2 over infinity, which is going to go to 0. All right, so what happens is that e to the x is much, much bigger than any sort of x to the n, any sort of polynomial. All right, exponentials are bigger than polynomials. So this guy is going to win out in the competition. All right, so if he's on the bottom and he's going to infinity, it's going to go to 0. Doesn't matter what the exponent is. All right, you could have like x to the 10th over e to the x. As x goes to infinity, the e to the x is going to win out. It's going to go to 0 because this guy's going to keep getting smaller each derivative. This guy's going to stay exactly the same each derivative. We're going to 0. All right, same with if e's on the top and x to the 10's on the bottom, the e to the x is going to win out. It's going to go off to infinity. So if we have e to the x on top, x to the 20th on the bottom, whatever, it doesn't matter. This is going to go to infinity in the end because the e is going to be bigger. All right, so that might help us here on the next one. So we're going to infinity. We get infinity minus 1. Sure, that's going to infinity. Infinity to the third, that's going to infinity. So we want to write out the limit as x goes to infinity. Have e to the x minus 1 goes to infinity or equals infinity. Same with the other side. X goes to infinity of x cubed also goes to infinity. So it's indeterminate. We're using L'Hopital's rule. So we say that this guy is now equal to the limit as x goes to infinity of e to the x. There's the derivative of the top. The derivative of the bottom is 3x squared. Still get infinity over infinity. So this is the limit as x goes to infinity of e to the x over 6x. Still infinity over infinity. We do it again. We still have e to the x on the top. He's not changing at all, but now the x's are gone on the bottom. So the top's going to infinity, the bottom is 6. So we're going to infinity here. So like I said, e to the x wins out. He's going to be stronger. All right, last one here. E to the negative infinity is 0. So this is going to 0. This is going to infinity. 0 times infinity was one of our indeterminate forms, but it's not one where we can do L'Hopital's rule. So we can rearrange this into limit. I should probably change colors here too. Shucks. The limit as x goes to infinity of square root of x, and we move the e down to the bottom. And it becomes e to the positive x. Voila. Now, what we want to say is the limit as x goes to infinity of the square root of x goes to infinity. Square root of infinity is still infinity. And the limit as x goes to infinity of e to the x also goes to infinity. So we've got the infinity over infinity indeterminate form. So we're indeterminate, don't forget to say that. And we're going to use L'Hopital's rule, don't forget to say that. So this is equal to the limit as x goes to infinity Derivative of the square root of x is 1 over 2 times the square root of x. Derivative of e to the x is e to the x. So on top, we're getting 0. On the bottom, we're getting infinity. We can write that. Both of these are saying that it goes to 0. So our answer is 0. All right, e always wins out. We had the e on the bottom, square root on top, e's going faster. All right, so that's it for L'Hopital's rule and indeterminate forms. And that is it for this section. Tune in next time. Get the homework done, please.